Okay, we're continuing with the hyperbola homework on page 375, 376. The homework was 11 through 17, and we are on 15. So 15, here's 15. So this is a hyperbola, and you can tell it's a hyperbola because there's a minus sign in front of the y squared term, and the x squared term is positive. So as long as one's positive, one's negative, it's a hyperbola. So we're going to complete the square twice. First with the x's, then with the y's. So we're grouping our x's and we're grouping our y terms. And then any term that doesn't contain an x and a y, we move to the other side. So the x's, we don't have to remove anything. It's already got a 1 here, so we're ready to go. So half of 16 is 8. 8 squared is 64. And that's what we're adding to the other side. These are going to cancel. So far we have a 0 on that side. So that means the x's look like this. Square root of 64 is 8. Half of negative 16 is negative 8. You can go either way. Now the y's, you have a little bit more work. We're going to take a negative 36 out. So that's going to be a positive y squared, and negative 72 divided by negative 36 is a positive 2y. Half of 2 is 1, and 1 squared is 1. So we're adding a negative 36 to the other side. Now, that's going to be negative 36 times y plus 1 squared equals negative 36. Because this is negative, we are going to be dividing by negative. So that's going to make this one a positive, and it's going to make this one a negative. This one's going to be the positive one. So I'm going to write that one first. So it's going to be y plus 1 squared over 1. This one's going to be the negative one. So I'm going to go x minus 8 squared over 36. That negative 36 is right there. I'm not going to write negative 36. I'm going to make that negative go out in front right here, and it's going to be right there. So a negative is free floating in a fraction. If you have a negative bottom, it can go in the top or it can go in the middle. I put it in the middle. Equals 1. So the center is 8, negative 1, and this one goes up and down because the y is first. So I'm going to add some graph paper here. So I'm going to get an x and y axis in here. I think I should have maybe made my graph a little to the left. 8, because 8 negative 1 is over here. Let me do that again. Sorry about that. I'm going to center this over here a little bit more. I did it again. Good God. Sorry. Try this again. All right, I think I know what I'm doing now. I'm going to put my y-axis like way over here. No, I think it's better. All right, so 8, negative 1. 1, 2, 3. So this is 0. 1, 2, 3, 4, 5, 6, 7, 8, negative 1. That's my center of my hyperbola. Now, it's going to go up and down 1. Okay, so your vertices, your a squared is 1. So a is plus or minus 1. That means you're going to go up 1, because it's under the y. You're going to go up 1, down 1. So those vertices are 8, 0, and 8, negative 2. Those are your vertices. 8, 0, 8, negative 2. Now, the number under the x is going to go left and right, but these are fake vertices. They're not really there because of the negative. So we're going to go 6 to the right, 1, 2, 3, 4, 5, 6. And 6 to the left, 2, 3, 4, 5, 6. So our box, oh, I didn't do that in line with the center. Wait a minute. It's going to go here. I'm going to put an x here and an x right here. So our box looks like this. This is our box. So our asymptotes are very wide. Looks like that. So our hyperbola is going to be really fat. That's what our picture looks like. So another thing that they want to know is your foci. Your foci formula is pretty much the Pythagorean theorem. So your c squared is a squared, which is 30. Actually, a squared is 1. B squared is 36. So it's 37. So it's about 6.1. Is like that. That's foci 1. And foci 2 is way down here. That's your foci. The closer this gets to the center, the more round it gets, like up here. The wider, the further these are, the wider this is. What else do we need? Asymptotes. So our asymptotes. Here's our formula. So if you don't know if it's B over A or A over B, just look at your box. Here it's rise over run from the center. So you're only rising 1 and you're running 6. So the slope's 1 over 6. So in this case it would be A over B. This is your asymptote. Oops, I forgot to put the y coordinate of my center in. So my center is -1, so this is y plus 1 equals plus or minus 1, 6, and then x minus 8. That's your asymptote formula. Hi.
Hi.
How are you?
I have a question.
Yes.
Will you tell some of your senior classes to vote for me?
For what?
Most likely to get teachers off topic.
Okay, I'll tell them.
Thank you.
15. So now we're doing 16. So some telescopes use hyperbolic mirrors. A light ray directed at one focus is reflected to the other focus. So hyperbolic mirror has a focus at 14,0. This is number 16. And a vertex at 12,0. When light is reflected from 14,0, it is reflected to -14,0. Find an equation that models the shape of the mirror. Find the width of the mirror at its focus. Find the width. At the focus. So this is, I think I'm going to go by twos. 2, 4, 6, 8, 10, 12, 14. So this is a focus. And this is a vertex, if you go by twos. So 2, 4, 6, 8, 10, 12. That's -12. And here's -14. So the center has to be 0, 0. And it's opening left and right because of the way they gave you the points. So you know that it's like x minus h squared over a squared minus y minus k squared over b squared equals 1. I think we can go ahead and find b. So we know that a is 12 because it's vertex being 12, 0 and the center being 0, 0. And the reason I know it's the center is because they said something about it. When light is reflected on this, it bounces off to that. So that's telling you that the center is 0, 0. Like it's the midpoint of these 2 points. So A is 12 and C is 14. So our formula is, we'll do it over here. C squared equals A squared plus B squared. So C squared is 196. A squared is 144. So B squared is 196 minus 144, which is 52. So B squared is 52. So we have x squared over 12 squared, which is 144, minus y squared over 52, because that's what we just found over here by doing our foci formula. B squared is 52. So this is our equation. That's Mr. Hewlin. All right. So 52 is, square root of 52 is a little over 7. Right, so if we were doing a box, 1, 2, 3, 4, 5. Oh, I forget we're going by twos. 2, 4, 6, 7. So it's around here. 2, 4, 6, 7. And so your box looks something like this. So just trying to get a better picture here. So again, this is a telescope. Okay, so let's say this is a telescope, uses hyperbolic mirrors. It says, find an equation that models the shape of the mirror. Find the width of the mirror at its focus. Find the width of the mirror at its focus from right here. Find this width. So since that is, so basically this order pair right here is 14y. So x is 14 and we don't know what y is. So we're going to find that. And this one down here is 14 negative y. We're going to try to figure out this width right here. So if we can figure out this y coordinate, we're going to know this y coordinate, and then we're just going to subtract them to get our width. So in order to do that, I need to plug in the 14 into the x. So I'm going to plug in the 14 here. So 14 squared is 196 over 144 minus y squared, or 52, equals 1. Solving for y squared. I would subtract this from 1. So you have 1 minus 196 divided by 144, which is negative 0.36. Let me change that to a fraction. You don't have to, but so that's negative 1336. Hi. Well, I like my door. Thank you.
I couldn't put occupied.
I like that.
I thought about it.
I was laughing at that all day today. I said, oh, they love me here.
If I could take a picture and copy it and print it, put occupied. I'm occupied.
I love it. Thank you. It helps me. I need all the help I can get.
Does the lock work better right now?
Oh, yes. It's so much tighter. Because I was going around like 7 times.
Yeah.
So I'm glad.
Yeah, I did have trouble with that Friday night. Okay.
Well, I'm glad. I feel safer now that I can lock my door.
We tore it apart and did what we could to get it adjusted. And now that hopefully it'll stay. If it acts up again, let me know.
Okay. Thank you so much.
I got a hammer for the next time.
Okay. So our missing order pairs are 14, 4.3, and 14, negative 4.3. So if you just figure out 4.3 and 4.3, it should be about 8.6. If I did this problem right. Let me see, is there an answer to this anywhere? I don't see an answer to this. 16. It says 8 2/3. I say we're pretty good. It says 8.6 feet. That's the width between the foci. They said 8 2/3 in the book. That's because they did all these decimals right here. So like if you saw this is really 4 1/3. 4 1/3 and 4 1/3 is 8 2/3. That's why they have 8 2/3. I rounded. Okay, so that's how you do it. So you come up with the equation, and then if you have to find the width, you know that this is 14. Like you're just trying to find this width right here. So you know it's 14 something. So you just plug the 14 into x right here. Subtract this over from 1. Then multiply both sides by negative 52 square root. And there you go. That's 16. 17. Okay, so compare and contrast a hyperbola centered at HK. Okay, hyperbola centered at HK that has a vertical transverse axis. So if I was doing that, if I was considering this, that means it would start with y. And the a squared goes with that one. So if it's vertical, y has to go first. A squared's always with the positive, so that's that. And then it said to consider an ellipse centered at HK that has a vertical major axis. Vertical major axis. That means that the a squared is with the under the y. So you'll notice the a squared is under the y. So these two look the same. Consider the standard forms of the equations in the coordinates of the vertices and foci. So the vertices would be, if you have an HK and you're going here and here, your vertices are going to have the same H. So your vertices would be H plus or minus A, comma, K. And over here, your vertices would be, you're adding to the y. So again, this is a hyperbola. This is an ellipse. See ya. So the A is here. So your vertices would, again, have the same H. Actually, I did this wrong, didn't I? This one has the same H, has a different K. I'm so sorry, that is wrong. Go back up to this one. This is H, K plus or minus A. This one is also H, K plus or minus A. So the vertices would be the same, the main vertices, the majors. And then the foci of this one, since it is C equals square root of A squared minus or plus B squared, your foci then would be past the A's, so they're bigger than the A's, so they're still in the same one. So they're going to have the same H, but it's the y coordinate plus or minus all of this. And then this one is C equals square root of A squared minus B squared. So it's almost the same, except that this is going to be A squared minus B squared. So for your foci, it's going to be H K plus C, H K minus C, where the vertices would be H K plus A, H K minus A. Up here would be H K plus C, H K minus C. So it looks to me like they're all the same. So 18. So 18's equation. So you're looking at this, let's look at the book here. And want an equation of this hyperbola right here. So do you notice how it's open up and down? And it has an A of 2, and it has a C of 3. So the focus is 3-way, and the A is 2-way, and it's up and down. Because it's up and down, we're going to have the y minus k squared first. Start with that. You have to have the right one written down before you can get it right. And it said A was 2. So this in the center is 0, 0. So it's going to be y squared. And I said the A was 2, so this is 4. X squared over equals 1. We don't know the B squared, but we do know that A was 2 and C was 3. C is a distance from center to focus. A is a distance from center to vertex. So here is your foci formula. So C squared is 9, A is 4, so B squared is 5, and that's the equation of your hyperbola. What is the equation of the hyperbola with the center at negative 2, 4, and a vertex at negative 2, 2? So, has a center at negative 2, 4, center, and it has a vertex at negative 2, negative 2. So right away, I know that it's here, here, and then it's going to be here and here. So we're looking for a y, and the center again was, what was the center again? Negative 2, 4. So it looks like y minus 4 squared minus x plus 2. So we're looking for that. And then the a, from here to the center to the vertex, looks like 6. So it looks like a is 6. That goes there. And I think I should be able to figure it out from here. So looks to me like it's got to be D. Looks like the only one it could be is D. That's your answer. Done.